I believe in user choice in their security model, as well as user choice in the extremes of security models, right? I feel like there should be a spectrum of how much you trust the developers. So if you manage a lot of money, you perhaps want to run this reproducible build.
Hot here.
Hi, everyone. Welcome to the Chaincode podcast. My name is Kara Lee.
And I'm Jonas.
I'm Murch.
And Murch is our brand new co-host of episode 8 fame.
We've already just given him the title. We're not even making him work for it. He just shows up, does his own episode, and then shows up for the next one. That's how it works.
You really, really made an impression, obviously. Well, for your debut episode as a co-host, who did you guys chat with?
We talked with Carl. We talked a little bit about his build and toolchain work. And then we talked about his consensus engine isolation and modularization that he's doing.
So you kept it light.
Yeah, always light talking to Carl.
Yeah, we didn't even cover any details.
Well, great. Well, we hope you enjoy our conversation with Carl.
So welcome to the Chaincode podcast, Carl.
Hello.
You know, we've been doing this podcast for a while now. How come you haven't been on the show yet?
I mean, we've been at home, and this is more of a...
We had a few episodes before that, though. I don't know. All right.
It's fine. We've got you now.
We'll try not to take it too personally.
Love you guys.
But today, we are going to talk about all things Carl Dong.
Woo!
Maybe start off with a little bit about what you've been doing in the break. What have you been doing since we haven't been in the office?
I've been doing a lot of stuff.
Okay.
I've been continuing my work on reproducible builds and the build system in general. And also I've been getting into the code base, looking at some cleanup stuff that can be done and what features they may lead to.
All right. Let's start from the top. Tell us about reproducible builds.
All right. So after I gave that talk last year about GUIX, I've been working a lot on that. And mainly this year, it's been a lot of getting things that were barely working into things that are nicely working. We can start with some context, I guess.
Yeah.
Well, like if you download a piece of software from the Bitcoin Core website or from GitHub or whatever, it's just like an opaque blob of thing that could contain any code that we want to, right? Like technically, BitcoinCore.com can serve up a binary that just steals all your Bitcoin, right? So how do people know that what they downloaded is what is intended or what is in the code base or something that they have reviewed? That's where you need reproducible builds so that multiple people can run the build and see that they got the same thing and that nobody inserted something malicious into the binary, right? And so
how do they make that comparison?
So they make that comparison by looking at the inputs and looking at the outputs of this process, right? So the inputs will probably be Bitcoin code base and some kind of,
the release tag, right?
Yeah, exactly. The release tag and the tools that are being used to build it, the environment, that's something that people don't really think about, but that's actually part of the input. And then you look at the output, which is, okay, now you have built a Bitcoin binary. And what does that look like? And you can compare the inputs and the outputs across multiple different builds and see if they are the same or not.
I think.
Cool. So how is this done now? Like, you didn't just come along.
Before me doing the GUIX build and everything, we were doing this with Gitian builds. And Gitian builds were very nice. The way that they worked was basically you spun up a Ubuntu VM, which is sort of the fixed environment, though it's not really fixed because every time you download a package, you could be downloading different packages. But basically, you ran the build in a very fixed Ubuntu VM with all the right hacks such that everything is the same. For example, we use things like fake time, which means that which is a tool that allows you to run any tool and it will report back the time as this time that you set. So that means all the timestamps that any program will ever see is the same. So these are like a few hacks that we sort of put in there in order to make all of these things work and end up with a reproducible binary. And I think Bitcoin was one of the first projects to adopt this reproducible builds approach. And when I saw that, and that was pretty inspiring. And in recent years, there have been more of a push towards a generalized, reproducible build ecosystem. A lot of Linux distros are adopting this approach now. Debian, I think, in the latest LTS release, has said that they're going to require new packages to be reproducible before they are accepted into their list of packages that they send to users. And also Arch Linux is making a lot of progress in this regard. And obviously functional distros like NIX and GUIX are, they're at the forefront of all this. They organize the conferences and people go, and yeah.
We'd like to thank our sponsors for this episode. This episode is brought to you by Capital Controls, because your money belongs to you, except when it doesn't.
So you mentioned that the timestamps were a big issue in the reproducibility of packages.
Right.
How do they do it? Do they have all their build processes also run on fixed timestamps?
So there are. So this is one good thing about sort of having upstream support. It would be very difficult if sort of Bitcoin was the only project that cared about reproducible builds. But now that more people are caring about it, there's reproduciblebuilds.org, which is like this organization of everybody who cares about this. People have rallied around the standard called source date epoch, if I remember correctly. So that's an environment variable that programs can implement in their own source code and abide by, right? So programs can, in their own source code, say, okay, now I have to insert a timestamp into the output. I'm going to check this environment variable and make sure that I'm going to check this environment variable and see if anything is set there. And if anything is set there, I'm going to put that timestamp instead of what I intended to do at the times as the timestamp. So that eliminates the hacky way of doing fake time, right? Because if you do fake time, then all timestamps are reported as that time, which is probably not what you want, especially if you do some kind of profiling or instrumenting or other things that you might need to do with time. But there, of course, not all software support this new standard yet, so it's sort of going along. But a lot of build tools are starting to honor this new environment variable, which is very cool to see.
So there was a Stack Exchange question actually on how to do a Gitian reproducible build today.
Yeah,
I looked into it, and one of the first comments that I read was like, well, great. So now I build this VM package to build reproducibly, but I'm trusting the person that packaged that VM.
Oh, for sure. For sure. So this is, and that's a great question, because that sort of gets to the root of why I want to do the work that I'm doing, is because he's absolutely right. If you are downloading this VM package, you are trusting whoever packaged up this VM, because again, it is an opaque binary that you're downloading, right? And not only that, you're probably, the first thing you're running inside your Gitian build is probably apt-get update and apt-get upgrade. You know, you're upgrading all these packages, and they are opaque binaries that somebody built. And so this is like a huge, how would you call this? Trusted seed binary, that binary seed that you're trusting. And my goal with the new kind of reproducible build system based on GUIX is to reduce that to as small of a trusted seed as possible, right? So GUIX is, you can think of it as Gitian, but with a much smaller trusted seed. In fact, what we foresee to be able to be done is to have a trusted seed of about 500 bytes of assembly, and it's just an assembly implementation of a hex decoder, that we can use to then bootstrap the rest of everything. So it will go from that to a higher level language that's a subset of C, to a larger subset of C, to C itself, and to TCC, and then into GCC, and then we can compile the rest of the world, is how it is. So instead of it being opaque binaries, these will be sources that could be read and understood by humans, which is, much better than, going through the binary and try to figure out what's going on.
Right, but strictly speaking, you'd still have to look at every package along the way, right? Or
right.
How do you update them?
You would not be able to. So the way that GUIX works is that it's by default source based. Mm-hmm. So basically, if you run a bootstrap build, it will download that 500 byte binary from a seed from somewhere, and then it will actually build every single step along the way up until it gets to GCC. So, that is the final goal, at least, is to build every step along the way up till GCC. So you don't have to audit all the outputs of those, all the opaque binaries of those, but you do have to audit the source code. And I don't think there's any way around auditing the source code until we can have some proof on ELF binaries or something like that. I don't think that's a possibility. Yeah.
What other projects are taking security this seriously, this bootstrapability?
I mean, as I mentioned, the distros really care about reproducibility. That's the things that they really want. Obviously, GUIX, aside from my use as a way to reproducibly build Bitcoin, is an operating system in and of itself. So that's one of the reasons why they care about bootstrapability really seriously, is that they want to be able to support all kinds of architectures and also prove that nothing malicious was done along the way. I think one of the important projects that take this seriously is Tor. So Tor actually, after Bitcoin got Gitian builds working, Tor took that work and made it their own. And I think afterwards they rebuilt their own tool and abandoned Gitian after a while. But I saw a post on the Tor mailing list, or the Tor bug tracker, that was like, hey, Bitcoin's doing this GUIX thing now. Maybe we should do it as well. Yeah, maybe if I have time, I'll help them with that when they are interested.
So you said that Bitcoin was the first project to use Gitian. Is Gitian a Bitcoin project?
I think so.
The author, I see Dev Random.
Yeah.
Over that, and he's a Bitcoin contributor, so I don't know.
Yeah.
So Gitian was actually created, but it wasn't something that was there before Bitcoin wanted to use it.
No, I don't think so.
Yeah,
And how old is it?
Oh man, I'm fuzzy on the history.
Okay, so we have this aspiration to get to both reproducible and bootstrappable builds.
Yes.
Tell us a little bit about the adventures along the way. What have you run into as you've been working on this? I think the first time you sort of went public with this was summer 2019 at Break.
Yeah. Yes.
And so that's now, it seems like forever ago, but only a little less than 18 months. So tell us about your progress.
One pandemic earlier.
Oh man. So I'll start with some overarching things that I have learned out of this, and then we can go into the details. One thing is that in build systems, you can get something hacky working really quick if you really wanted to hack around things. But to get it working nicely, as in getting it to work in a way that will continue to work as packages get updated and everything, is
reproducible, one might say.
Right, yeah, exactly. Reproducibly
all sorts of operating systems and architectures, right?
Right, exactly. And reproducibly, portably, nicely is another thing. And this arises out of the fact that build systems, a large part of what another word, I guess, for a build system is a tool chain, and it's literally what it is. It's a chain of tools that are supposed to work together nicely. Unfortunately, they always overpromise and underdeliver. As in, tools say we support this and that and this and that, and then they actually support this set of features on the code path that is tested most, and on all the other code paths, nothing works properly. It's a mess. And so I had to go into a lot of this. So, I mean, I remember clearly when I was doing Windows builds, the hardest thing was to get the builds to be reproducible. We had the builds working, but we had these massive diffs between the outputs of the Bitcoin Ds that were built, and we had no idea where they were coming from. We took a look inside the binaries, but they were just a mess. So the way that the approach that I took was look at where it is in the binary, and sometimes you can figure it out. Sometimes you can't. And what you have to do is compare the intermediate byproducts of the build system, right? So for example, if it's an archive files are made by, .a files are made by, archiving all of the object files, right? So if the archive files are different across two builds, let's look at the object files. Are they different, right? And so all of these things play into if it's reproducible or not. And the end result of doing Windows builds was that we found that GCC 8 had a reproducibility bug in how it built libstud C++. So libstud C++ is the standard C++ library with things like vectors and all of that. It is shipped inside GCC. And when you build GCC, it will build a libstud C++ because GCC we configured GCC to enable C++ as a language. So libstud C++ .a, as in the archive file, was non-reproducible, but all the object files that make up this archive file were reproducible. So it was actually the ordering of these object files inside this archive file that was non-reproducible. If you if you think about an archive file as just multiple object files, and so we found so this comes to when you put objects in an archive file, sometimes some build scripts will use find. So they'll just do find all .o files and then put them in an archive file and whatever. And that is actually wrong. That is non-reproducible because when you do find, the order of objects that find returns is dependent on basically just whatever the file system wants. They can return in whatever the file system wants to return. And so you have to sort the output of that.
You basically went into GCC 8 and added a .sort to the building of C++, the standard.
Yeah. So this is why I feel like build system work is so weird in that when you start this detective work, right, you have no idea what anything is, and then you have 5 different theories, and then you try 5 different patterns.
None of this is going to be documented, obviously.
Well, I in my commit messages, I try to document as much of the rabbit hole as possible and that's sort of one of the things that I want to do is because, I feel like a lot of, build system tools and build system tools, they're done with the philosophy of, hey, I had to go through this, so future people have to go through this. This is the hard way to learn and whatever. And I don't think that should be the case. So wherever I touch, I try to first of all do it nicely so that it's sort of self-documenting, and also in the commit messages I talk about where you could go wrong, where you could find the sort of misleading evidence that will, take you a week to get yourself out of.
I mean, that's one thing if you're doing this for the Bitcoin project, and those commit messages will live in Bitcoin Core, but there's no documentation on GCC, on et cetera.
So there actually is this specific bug I opened a pull request to reproduciblebuilds.org because I found this to be just a mind-bending bug. I opened a pull request and they put it in their wiki. So people in the future who are building with GCC version less than 9, they will know how to make their things reproducible.
Awesome. Anything else you run into?
Oh yeah, I mean there are so many things I could talk about. So with the Windows GUIX builds itself, all of these things, most of these things I try to upstream. So for example, NSIS, which is a tool that we use to build Windows installers for our Bitcoin releases, I had to bump it up to 3.05 upstream in GUIX so that it would be maintained and everything. And the reason why I wanted to do so is because coincidentally, the Electrum devs put a patch in there that fixed one of their reproducibility issues. So while I was going through that, I was like, okay, if that might be something that we need in the future, I'll just do that, which is really cool. As in, sort of the Bitcoin open source software community cares that much about reproducibility and everything like that.
So it sounds like there's a broader movement now of more projects caring about that, and
for sure,
by upstreaming stuff and collecting it on, you said reproduciblebuilds.org, collects this information, and then perhaps also, I mean, you said it only affects up to GCC 8, so after GCC 8, other versions were reproducible?
Right. So that bug from before, it's even trickier than I described before. So after GCC 8 and GCC 9, they fixed this in GCC 9's own version of libtool. And the thing is, when I was doing this at first, I didn't realize that they had already fixed it, because this was fixed upstream in libtool in version 2.7.7b. And in GCC, when they pulled it into their code base, they pulled 2.7.7a and then fix it locally without pulling the change from upstream. And so it was just a mess. People vendoring different stuff and getting it fixed. So that is all described on the reproducible builds wiki entry that I put in there just in case it helps somebody in the future. But yeah, that was a big thing. One of the things that I learned that might be helpful for anybody else who tries to do reproducible build stuff or just build systems in general is look at what Debian does. Honestly, look at what Debian does. So many times I've been, stumped by this reproducibility thing or this build error for days, and then I think, okay, let's go to the Debian repos. So the Debian folks have all of the patches that they apply, all the build scripts that they do. They're all in Git, and I go there and I look at their patches, and they have a lot of patches that fix reproducibility issues, and that's why it was so helpful for me that we started out with Gitian, right? Because Gitian uses Ubuntu, which is based on Debian, so I sort of had a source of truth to look to. And so a few examples is, for example, when we were making Windows builds reproducible. So a toolchain consists of, I'm just going up a level, when a toolchain sort of consists of three main things, a lot of main things, but the main part is, a compiler driver like GCC along with all of its binaries, and sort of bin utils, which are the utilities that you use to manipulate binaries. And bin utils is, again, this is one of those things where it's supposed to work together, but sometimes it doesn't. Bin util is supposed to be kind of compiler driver agnostic, but it really isn't. But for example, in binutils in recent releases, they have added a configure flag, which enables determinism in their tools, which is, again, great. This is a community-wide effort to get things to be deterministic and reproducible. However, when you turn that flag on in configure, it makes all of the tools deterministic, but in the LD linker specifically for Windows builds, it doesn't turn on the determinism flag, which is, one of the things. Again, this is the overarching context, right? Things are supposed to work well together, but they don't. So this is one of the things that I found in Debian's repository that was extremely helpful, and that flag makes sure that when we link together, it sets the this deterministic mostly means the user ID is 0, the group ID is 0. That's sort of the really easy things to leak into non-determinism, and the timestamp is like 1 or something reasonable, and deterministic ordering. One of the things, that just came to my mind, one of the things about sorting find output or sorting directory listings or sorting symbols or anything like that is it's actually not enough to use sort. Because sort is locale dependent, so you actually need to set your locale to a deterministic locale before you sort, which is again one of those things where it's just like, why doesn't it work the way I want it to? But yeah, that was really cool. We found another tool, DLL tool, which is Windows specific, that the files it outputs has prefixes tied to that tool's process's ID. So like its PID is the prefix of all the files that it outputs, which it just makes no sense at all to me. But that's just the way it works. That's a source of non-determinism, right? Like your PID could be any number basically, and obviously like things likegendef, which includes like a date in its output, which is a big source of non-determinism. But yeah, it was just like whacking things, making them work.
Turtles all the way down.
Yeah, exactly. Turtles all the way down. Yeah, exactly.
So we talked a little bit about how multiple people might reproduce a build in order to provide the binary on, say, bitcoincore.org or bitcoin.org and other sources where you might retrieve Bitcoin. They start out with the same inputs with the release tag, build it from source, use this Gitian or GUIX set up to have a shared tool chain that is reproducible as well. And then they arrive at the same package.
Yeah.
Should everybody do that at home now? Is that something that every single Bitcoin user should do?
So I believe in, and this is just a personal opinion, but my personal opinion is I believe in user choice in their security model, as well as user choice in the extremes of security models, right? I feel like there should be a spectrum of how much you trust the developers. So if you manage a lot of money and you perhaps want to run this reproducible build just to see that everything is being built the way that you should, and this is one of the reasons why we have source-based distros like Gentoo, right? Like Gentoo is you just build the world from source, right? Because you don't trust anybody. I would say that is sort of meaningless without a way to actually bootstrap everything like GUIX does. But you should build from source if you trust no one. But one of the great things about reproducible builds is that it allows for people to attest to results, right? So you can almost, I don't know too much about Web of Trust. I feel like this is a big word, but like you can almost look at your web of trust. Like people, who do you trust to build this correctly? Who do you trust to be adversarial enough such that they're not going to lie together or things like that, and look at their Gitian signatures and look at what they've attested to and see that, okay, this build is probably reproducible, this build is probably okay.
And that's right now mostly the maintainers, right?
Yes, right, exactly. That's mostly the maintainers, though this could be run by anybody.
There's a few people that aren't even code contributors that have figured out how to run the Gitian builds, and they add their signatures to it, and that's great actually, because they're not part of the developer cabal, and you can still make the attestation that you took a specific release tag of code and ran it on a separate machine, and you got this tag. Sorry, the hash, I guess, is what you in the end compare, and while you might not have compared the code itself, you compare the process and you show that you could reproduce the building step of it. And then there's other people that might review the code and attest that the code is fine and got released. People sign off on a release before it's tagged, right?
We'd like to again thank our sponsors. This episode is brought to you by Capital Controls, because nothing says you can trust the value of our currency by just banning you from cashing out.
So this also ties back to another thing that I wanted to talk about, which was we want to make this process accessible to as many people as possible, right? So, for example, when I first started to try to run Gitian builds and whatever, it was extremely hard because I think there were 2 tested paths that were on Ubuntu and Fedora, and I was running Arch Linux at the time, and somehow, things would break. Like I was on LXC version 3, and the instructions were for LXC version 2, and basically the only thing that worked was like Docker on Ubuntu. That was the only easy path that worked. And so being able to get it on GUIX, where everything runs in a Docker container, where we have pinned everything. For example, we use the nicely named GUIX time machine command to roll the system to a specific commit of the GUIX distro. Is really nice for being able to reproduce bugs, being able to look at that. And I think the requirements for GUIX are just like a sane Linux kernel with namespaces enabled, which has been enabled since a few LTS versions ago, and so I think that will be very nice, and I hope that with that we can encourage people who run different distros, not only Debian-based distros, to be able to run this build for themselves. And they don't need to attest publicly in Gitian.6, but they can if they want to, and they can just prove to themselves.
Can I ask a basic question?
Yeah.
Those hashes, how are they produced? Is this just a hash over the binary?
Yeah. They're just a very simple SHA-256 sum over the binary, which is really nice. Yeah.
Cool. Awesome. Do you want to talk about your Mac Toolchain editors?
Yeah, for sure.
Cool.
Yeah, I'd love to talk about that. So going into the Mac OS Toolchain. So our Mac OS build system is mostly 2 things, a toolchain and an SDK. And let me back up and give you some context here. You're basically not really supposed to, not supposed to, but it is definitely unsupported to cross-compile for Mac OS from, it is definitely not supported to cross-compile for Mac OS from Linux.
Okay.
Or from any other operating system. And
Steve Jobs wanted it.
Exactly. That's how Steve Jobs wanted it. And so I think the way that we got this to work was this was before I was around, but this was, I think, Corey is doing. One of Corey's first contributions was making Mac OS cross compiles work for Bitcoin, and the way that he got that to work was to lock everything down. As in, what we use for our toolchain is a version of Clang that is downloaded from llvm.org. Yes, that's a trusted binary. Downloaded from llvm.org that targets, I guess it could be the API, but basically it targets the Ubuntu distro.
Got it.
Right? But that means that, again, you can't run cross builds from things like Arch Linux or any other thing to Mac OS. So he pinned it at this specific binary just because when Apple releases an SDK, it releases an SDK and it says, and it couples this SDK with a specific Clang and with a specific, with a specific tool chain, right? So when he was doing this, they released the SDK and the SDK was pinned to Clang 3 point something or something like that. And throughout the years, when we bump our Apple SDK, we also bump the tool chain to sort of match that. And so that's how normally our thing is constructed, right? And so let's talk about how we do this, because I don't think cross-building for Mac is something that most developers have done, just because it's such a big hassle. And one of the things I wanted to do when making Geeks Build for macOS is just to make this less of a hassle, because it really doesn't need to be that way. So the SDK, one of the things about making the SDK is that you need an Apple developer account. There's no URL to wget the SDK. You need to go in and you need to have the authentication cookie set so that you can download this SDK. And so we download this SDK, and it's in a proprietary format that ends with .xip. It's a zip file, but not with a Z, XIP file. And basically, the way to extract that is we need to compile a program called ZAR and a program called PBZX, and then pipe this XIP file through ZAR, and then PBZX, and then CPIO, and then finally we get an Xcode.app that is multiple gigabytes, which is not the best. And so from that Xcode.app, we have basically we have documentation on what I would only call our incantations. I feel like these are not invocations; these are incantations, because we're compiling with Clang with fixed R paths and everything. These are incantations to extract the SDK from this Xcode.app, and then we can use this SDK with our toolchain. And all of this is there are so many ways to fail in every step of this incantation that it is incredible. So one of the things I did with this was to Python all the things, basically. What I found is that Python standard library, this is one of the great things about programming languages that are basically universally available with a big standard library, is that Python has this great standard library that's actually more flexible than command line tools. I tried to write this in Bash first because I love Bash, but I just found it to be much easier in Python. I wrote a Python script that was able to extract SDKs in the right way, and then Corey contributed a part of this, which was he was able to extract the .xip file without needing to compile ZAR or PBZX. He did some nice bit fiddling, and now it's just two Python scripts that you run on one file, and there's no compiling this application with Clang and then having to do all this stuff, which was really great, and that simplified a lot of stuff, and hopefully it will lead to much more people being able to do this process in the future.
So there's not a lot of you doing this process of review and looking at your PRs? Like, it's you, Fanquake, Corey, Shores is doing a decent amount of testing, but
So-
like, how do we move forward when there's, there's 4 people that we're all relying on?
I don't know. I don't think there's only 4 people. I think there are more people, because with things like the macOS toolchain changes that I'm talking about, right? We do this, and then a lot of forks of Bitcoin. If you go back to that PR, you'll see at the bottom a lot of forks of Bitcoin. They do their own review, and then they pull this into their code base, which I'm very happy about, which means, they might submit bug fixes and stuff in the future for, the random scripts that I write, which is fantastic.
I mean, I can just trust the binary up there, right? It's been signed by the release key of the Bitcoin maintainer. Mm-hmm. And there's a bunch of people that in the process of creating that binary did the reproducible builds already. So if you said that people can choose different trust levels. Mm-hmm. If my trust level is, I already trust the developers for the code, the same developers, a bunch of them produce this reproducible builds in order to come to consensus that this is the release that they wanted to produce. Mm-hmm. And it's signed by the appropriate key. Mm-hmm. So I trust Vladimir's key, and I trust the developers to produce the right thing. Uh-huh. What do I gain? Don't I open myself up to other sorts of attacks by like installing maybe the tool chain to do reproducible builds or something? Is it maybe not even in some scenarios safer to just go with?
I mean, if you already trust, so going back to what you said, if you already trust the maintainers and trust people who are signing the binary to not do anything malicious, the benefit to you of reproducible builds is that you can think of it as a way for these maintainers that you trust to check themselves. You understand what I'm saying? Because before releases, people run, the maintainers run reproducible builds to check amongst themselves that everything is all right.
So I think I get the point that the reproducible build helps maintainers to come to a consensus that they agree on what they had for a source and what the output of that was.
Yes.
So to, as a group, authorize something, right?
Exactly.
Or authenticate something.
And the fact that, this is reproducible in the other sense, as in reproducible outside of this group, it means that if your if your level of trust shifts a little bit towards, I'm not entirely sure that this group of maintainers is not collaborating, you can go check them yourself.
Right.
Yeah.
And even if you don't program or don't want to go through the code base yourself, you could pay someone to review what exactly is in the release tag and to do the reproducible build, and then come basically do an audit.
Yeah, exactly. That's exactly what it is.
That was part 1 of our interview with Carl. Stay tuned for the second half, released in a couple of weeks.
Well, what a great sit down with Carl.
It was a nice sit down.
You guys covered a lot.
Oh, yes. I especially have a new appreciation of how much detective work and debugging work it is to get something reproducible. Yeah, I mean, if you're writing code, you're at least staring at your own stuff and you have an idea of where you're looking. But you're diving into this whole tool chain here, and you have no idea at what level of the stack something is going awry. And I think that just has to be really appreciated.
Yeah, I think something that stood out to me was hearing about Gitian and sort of how it grew up around Bitcoin. Mm-hmm. I guess it's undetermined whether it was a Bitcoin project or Bitcoin was the first to really use it. But these other projects that have adopted Gitian and now GUIX. Bitcoin is sort of leading the way in being paranoid about what's happening upstream and guarding against it.
Yeah, it's kind of interesting. Sometimes we're a little close to the whole project, but also, for example, on GitHub, it's just been breaking a few of the previous assumptions about project interactions, how much work there's going to be in one code base and things like that. So it's sometimes nice to see how it impacts other areas of software engineering.
Great. Well, we hope you enjoyed. Thank you for listening. If you'd like to learn more about Chaincode, or Carl for that matter, you can go to chaincode.com. And where else? Where else can they find
Twitter.
us?
Definitely go to Twitter.
You can find us on Twitter at Chaincode Labs.
Thanks, everyone.